Hello, welcome to Class 2, Section 2. This is about planning and deploying production standard Hadoop cluster. In here, we'll be looking into how to plan production Hadoop cluster, the basic architectures of HDFS2 and MapReduce, HDFS components, and a sample of Hadoop cluster in production. So let's begin with how to plan a Hadoop cluster. Right. The first thing we need to do is estimate the size of current and future growth rate of the data. So for example, if you have the current data size is 100 terabytes and the projected rate of growth is 2 terabytes per month. So this is the setup of existing data and the future growth rate of the data. We'll be planning Hadoop cluster around data, which is very important. The next thing we need to look into is how are the workloads for the Hadoop cluster. So how your organization is having the workloads. If it is a balanced workload or it is more resource intensive, taking more IO and more CPU processing. So if you need real-time processing, you need to have different tools and technologies such as Apache Spark or HPCC we discussed before. So if you want more IO, you need more data and more IO bound capacity to the cluster. So these kind of things needs to be taken into account when building a Hadoop cluster. At the moment, Hadoop 1 and Hadoop 2, there are two versions currently in the market. However, if you take Hadoop 2, it supports latency processing as well. Earlier versions of Hadoop only support batch processing, so you can't have low level data. For example, if you go to a bank, you need transactions happening so fast. So you need faster reads. So that is not possible in Hadoop earlier, but now they are implementing low latency data processing as well, right? So you can also take different monitoring tools, for example, Nagios, Ganglia, these kind of tools, and do a pilot project. So you can define how much CPU, how much RAM, and how much disk is being consumed by the teams for query processing and MapReduce processing. So a sample setup for analysis and estimating the future Hadoop cluster. So this will be a production standard. So we'll do a pilot project and we get the results and incorporate them in the production planning, right? So step 2 is aggregating HDFS block replication factor, right? So the default factor for HDFS is 3. We'll see this in detail in later sessions. So for example, if you take a block, right, a block in HDFS is either 64 MB or 128 MB. The older versions are 64 MB and the newer versions like Hadoop 2, they are of 128 MB. So if you take 1 GB of file, it will be divided into 128 MB blocks, but the last one won't be of the same size of 128, right? So each of that file block, the 128 MB block is replicated 3 times. So if you take 3 nodes, it will be put into those 3 nodes randomly. So one node will have one block and another node will have the same block somewhere else. So the main reason behind this is even though you lose the slave node, the job which is running still can have the data somewhere in the cluster and continue with the operation, right? So from step 1, we have the current data size, estimated size, and HDFS block replication factor, and we have estimated projected growth of 2 terabytes per month, right? So planning for 12-month growth would be 2 into 12, which is 24 MB for 1 year. So you need to bring in slave nodes to incorporate that data and get processed, right? There is a note as well. because organizations have some data archival procedures and disposal policies, and it is up to the company. This is only a sample estimation what we are giving here, right? So the hardware requirements. So Hadoop works on master slave architecture. So HDFS master, HDFS slave. Similarly, we have master MapReduce and master slave MapReduce, right? So these nodes will be thousands of nodes. We are taking only 35 node cluster to demonstrate here as an example. So it may be 100, it may be 1000, right? So we plan the master nodes and we plan the slave nodes. So you can see there 4 times the master nodes, which are server grade, and CPU cores which are 16 into 2 gigahertz, 16 CPUs, RAM 32 GB, and hard disk 2 terabytes. And the slave nodes, which are commodity hardware, so you have 31 nodes there, and CPU 8 into 2.0 gigahertz, 8 cores, RAM is 16 gigabytes, and hard disk is 12 terabytes. So why is the master having less hard disk than slave? The important point here is the work actually done, the MapReduce processing or your query processing, all the batch processing is done by the data nodes or the slave nodes, right? They are the workhorses of Hadoop cluster. So all the pressure is on the data nodes. They are fast failing. So if you have a failure on a data node, you can remove it, but still you can continue with the processing because the data is not lost. The data is somewhere replicated and it is readily available for master to continue processing, right? So that is the important point and the reason behind having less terabytes for the master and more terabytes for the slave. So you can see we have a 35 node cluster, and each of the block size will be having into 128 MB, as we'll go with Hadoop 2. If we are going with Hadoop earlier version 1.2, which is stable version, it will be 64 MB. But Hadoop 2 is more advanced and more deployed now because it has advanced cluster managing capabilities than Hadoop 1. So we move on to the next one. So basic HDFS and MapReduce architecture. This is basically Hadoop 2 architecture. So if you see Hadoop 1 somewhere, if you find any link, or I'll pull it 1 second. So here is the Hadoop 1 cluster. You can see the name node, job tracker, secondary name node, etc. So the DN means data node and TT means the task tracker, right? In Hadoop 1, we have name node as a master node for HDFS and a job tracker as a master node for MapReduce, and data node as a slave node for HDFS and task tracker for MapReduce, right? So the master nodes they control the slave nodes, and they pass on jobs and requests to the slave nodes, and they work as a workhorses and they provide more processing power and data storage, right? The distributed storage is handled by HDFS, which is Hadoop Distributed File System. We'll see in our next class in more detail of how to use DFS, right? And the task tracker, which runs basically MapReduce jobs, which are basically maps and reduce tasks, taking various combination of classes like select and reduce and combination, sorting, merging. All these sort of jobs are taken care by task tracker, and they are set into racks and connected by switches with the internet, and you can access it through the client. So that is how the Hadoop cluster works in production and Hadoop 1. So next move on to our architecture. So this one is Hadoop 2. So what we have here is MapReduce is completely changed, right? There are only minor changes in HDFS. The MapReduce is completely changed. It is provided with a new system called YARN, which is yet another resource manager. They call it YARN, Y-A-R-N. So the job tracker, which was a master node for MapReduce in Hadoop 1, was divided into three types here. So I'll be explaining them later in administration part. So for here, the YARN is a MapReduce framework, which is called MRv2, MapReduce version 2. So the HDFS master node runs the name node daemon, and it connects to slave node running data node daemons in each of the slave node you can see there. And the MapReduce master node, also called as YARN, which runs the resource manager, which manages the cluster resources for MapReduce jobs, which has scheduler and application master. So it controls the YARN node manager, which is again called container and application master. Those are the two components in YARN slave nodes, which is basically the node manager, right? HBase is a Hadoop database, which is basically a NoSQL provision from Apache, which basically runs on top of Hadoop cluster. So HBase has new architecture in Hadoop 2, and it got Hadoop HBase master server and HBase region server, whereas HBase region server is a slave node. It also requires Zookeeper to run along with it. So we'll be looking that one into in the administration of Zookeeper, and why we need HBase to run Zookeeper as well, right? And rest of the slave nodes are of MapReduce, which are YARN node manager, right? That is the basic architecture for HDFS and MapReduce, which is basically Hadoop 2, right? Move on to the next one. So we can see some HDFS and MapReduce components. So the name node maintains and manages blocks, file system tree, image and edit logs, which are basically to pass on to all the data nodes. So image and edit logs are required by data nodes to capture the metadata continuously, and they also pass on them to standby name node or secondary name node, which is providing high availability, right? So the important files are image file for metadata, checkpoint for persistent record of image on file system. So it is for providing persistency, so not to lose the data. Journal to store modification of log of image stored in local file system, which is also called quorum based journal, which provides a kind of high availability architecture, right? So the HDFS data node are slave nodes which provide power to run the jobs on Hadoop cluster. We already spoken about that. They also store and retrieve blocks, report back to name node periodically with available blocks, right? So that the name node can allocate the blocks again. We'll see all these allocations and replications in HDFS DFS command while we are doing Hadoop HDFS cluster administration. Yeah, we'll see also the MapReduce jobs. We'll be using MRadmin and RMadmin, which are new tools. So the MapReduce job tracker, which is in Hadoop 1, and in Hadoop 2 it is also called resource manager. It delegates jobs to YARN node manager using FIFO scheduler. Its main activities are read job files from DFS, maintain queue for job splitting into maps and reduces. We already have spoken about that. Assign jobs to task trackers, right? So the task trackers in Hadoop 2 are called as node managers, right? So this is how a production cluster look like. So you have the gateway, HDFS master node, YARN resource manager, and HBase master. You can see all the slave nodes here, and you can see the master nodes there. So that is how we set up the production cluster, right? The number of nodes and number of the hardware requirements and the architecture of the data center planning, it all depends on your workload and how your company is operating and how much data you have and how much is your projected growth rate of the data, right? And how fast you need and how batch processing you are. So all these parameters should be taken into account while creating the cluster. So points to remember: planning a Hadoop cluster. We have seen how to plan and basic hardware requirements. We have seen the HDFS2 and YARN MRV2 architectures, which is MapReduce version 2, an example of production Hadoop cluster, right? This is end of the section, right? We'll see you in the next section. Thank you.